So this problem is as follows. At night, a 6-foot tall man is walking away from a 20-foot tall streetlight at a speed of 7 feet per second. Question A asked, how fast is the tip of his shadow moving? B, how fast is the length of his shadow changing? And C, how would your answers change if the man is walking towards the light as opposed to walking away from the light? Let's start by drawing a little diagram here. Let's say that this is the ground. And here's the light post. This is the light right here. Let's say the man is located here. This is his head. This is his feet. This is the base of the light post. The light is going to be emitting light rays like this. I kind of missed his head there. I'll fix that in a second. And this his body is blocking the light in this area right here. This is all going to be dark, and over here this is all going to be light. But since the light is shining in this direction and his body is here, this is all going to be dark, and therefore his shadow, this is the tip of his shadow, and all of this is the length of his shadow right here. So if I put a little arrow here, this is the tip of his shadow. Now he's 6 foot tall, so we can put a 6 there, and this is 20, the height of the lamppost. And why don't we call this entire length from the tip of the shadow all the way to the base of the lamppost, let's call that Y, and from the man's feet to the base of the lamppost, let's call that X. Now, I think we should think about what we're given and what we want in this question. The given information is that he's moving at a speed of 7 feet per second. So the man's feet is moving away from the lamppost, the base of the lamppost, at a rate of 7 feet per second. So that means dx dt is equal to positive 7. I just want to quickly mention, I'm looking ahead a little bit on part C. If the man was walking towards the lamppost, then x would be getting smaller over time, and that would mean, excuse me, that would mean dx dt is negative 7. But for this question, part A, he's moving away from the lamppost, so it's positive 7. What are we looking for? How fast is the tip of his shadow moving? Well, the tip of his shadow is right here, and we can determine the speed of the movement of the tip of his shadow by looking at the variable y. Y is measuring the distance from this stationary point here. So that means we would like to find what dy dt is. This is question A here. So that's fine. I guess the next thing that's maybe not obvious would be, what is our equation? Well, we can use similar triangles for that. This is a right angle. This is a right angle. These two triangles are similar. The big triangle here, why don't I label it to make it a little bit clearer? How about I call this ABC? A is the light, B is the base of the light post, C is the tip of the shadow, D is the man's head, and let's call E here the man's feet. By similar triangles, and just to be precise, exactly what are the two triangles that are similar? Well, triangle ABC is similar to DEC. Since those triangles are similar, we can use the fact that the ratios of their sides are the same. So 20 over 6, those sides correspond. Also would be equal to the ratio of this long side here, side BC, over EC. What is the length of BC? It's Y. And now how about the length of this little side here, EC, the shadow? Well, if this entire thing is Y, and this part is X, right here is going to be Y minus X. And so therefore that's going to be X. This long side, BC, is length Y, and this little side EC is length Y minus X. And so that ratio is equal to this ratio. So there's our main equation. Why don't we simplify this a little bit? Let's cross multiply. So we get 20 times y minus x equals 6y. Let's distribute this across. And if I bring the 6y over, it'd be 20y minus 6y, which is 14y. And then I bring the minus 20x to the other side, it becomes positive 20x. Divide both sides by 14, so y would be 20x over 14. Let me move up a little bit. So y is, why don't we simplify that by dividing the common factor of 2 out? So it would be 10x over 7. So this similar triangle equation reduces down nicely to y equals 10x over 7. And now we're ready to implicitly differentiate that with respect to time. So why don't I do that over here? Dy dt would be 10 over 7 times dx dt. Now we know that dx dt is 7, so we can fill that in. 10 over 7 times 7. Those 7's cancel. And we're left with 10. What is the units on that? Well, it's feet per second. And that's actually the answer for part A. We wanted dy dt, and here we have it. It's 10 feet per second. So the man is moving at 7 feet per second, but his tip of the shadow is actually moving at 10 feet per second. So for part B, how do we do that? Well, for part B, we want to find how fast the length of his shadow is changing. Why don't we... So his shadow is this dark area here that I indicated. Well, let's give that a new name. Let's just call that L, the length of his shadow, okay? The length of his shadow, as we already kind of mentioned, is y minus x, right? Let's implicitly differentiate that with respect to time. So dl dt is easily found. It's just dy dx minus, it's dy dt minus dx dt. And the thing is, we already know these values. Dy dt, we just found that a second ago. It's 10. And dx dt is given to us. It's 7. So 10 minus 7 is 3. And that's also in feet per second. So what that means is every second that goes by, the length of his shadow increases by 3 feet. That completes parts A and B. Now how about part C? What does C ask again? How would things change if the man was actually walking in this direction, towards the light? Well, let's think about that for a moment. As I kind of mentioned before, if he's moving towards the light, then dx dt is actually going to be negative 7, right? Why don't I just grab another color here? And let's just quickly just write in some changes. So that would be one change. Dx dt would be negative 7. This argument that we did right here for similar triangles, that wouldn't change at all. So that's fine. Then after that, we went over here, remember? This differentiation is fine. But right at this stage here, we would plug in negative 7 here. So that would be a change right there. And then this answer would come out to be negative 10 feet per second. So what that means is that his shadow is actually, his shadow of course would be moving, the tip of the shadow would be moving towards the base of the lamppost, since the man is moving towards the base of the lamppost. And the speed of his shadow is actually the same, except it's 10. Well, and it's just moving towards the lamppost instead of away from it, like it was before. And how would part B change? Well, the dy dt, I'll just do it right here. Dy dt, like we just saw, is negative 10. And the dx dt, as we wrote up here, is negative 7. So we'd have negative 10 minus negative 7. Those negatives make a plus, so it's negative 10 plus 7, which is negative 3 feet per second. And so notice actually the answers are the same as part A and B, except they're just negatives of the answers we had. Instead of 10, it's negative 10 for A. For B, instead of 3, it's negative 3. And so that kind of makes sense. And that's really the only change that would occur if the man was moving towards the light instead of away from it.